Some time to. All right, so remember bar graphs, spaces in between them, histograms, no spaces. Line graphs, really great to show change over time, right? You must have some sort of time period going on for a line graph, whether it's over days, over years, over hours. It shows things over time. Hi, thank you.
Whose is that?
Not yours.
What?
Thank you.
Are you leaving?
Yeah, I'm leaving it. I'm not leaving this hour. I'm leaving this
Oh, good,
hour.
good.
Me too.
All right, so we all know what a line graph looks like. We've all done it before. We've all seen them. They show change over time. Dot plots or line plots. It's a graphical display of data using dots or X's. This is one that you might have seen before. I'm sure you have. You're probably not as familiar with it as the bar graphs or the line graphs. It's a really good way to show relative size. Easy to see which is most and least. Very similar to a bar graph, except it uses dots and it uses X's. And it almost looks exactly like a bar graph, just without the bars. A lot of times you won't see a y-axis on dot and X plots because each one represents one unit. And that's the real difference between the dot plot and the bar graph. Okay? Rest of these you may not be as familiar with, so we're going to go practicing them. A pie chart. You should all be familiar with a pie chart, or a circle graph. Right? That is something you should be familiar with, but we want to redo it because you may have forgotten how to make one. I don't know. We should still know how to make one.
We need to make one?
We are going to make one. If you go to the page where there's the open circle cue, we're going to fill that circle in. You just want to double check. So, a special chart that uses pie slice to show relative size of data, otherwise known as a circle graph. It's a really good way to show relative size. Easy to see which movie types are liked, which are least liked at a glance. So, we use it when we really want to show the sizes of things, which things are liked, which are not liked, or which are more prominent, which are not prominent. It's really easy to just look at a circle graph and figure out, well, the bigger ones are the more prominent pieces. So, what we need to do is we need to change it to a percent and then change it to degrees to figure out how to make our circle graph here. Well, how do we change it to a percent? Divide the number by the total. So we're going to take like apples, 79, and we're going to divide by our total of 180. Where's my note packet? I not bring it over?
I got you.
You got me? What do you got, Q?
43. What do you want to round?
Round to the nearest whole percent, please.
44.
44%. All right. Oranges, we do take 14, divide it by 180. You get 8%. Bananas, 13, divided by our total of 180.
7%.
7%. Kiwis, 22, divided by our total of 180.
12%.
Blueberries, 23, divided by our total of 180.
13%.
13%. And then grapes, 29 divided by our total of 180.
16%.
16%. All right. Now, most of you could probably fill in your circle graph from here, right? The circle's worth 100%. But what I want to do is I want to change it to degrees. So I know a circle has 360 degrees in it, so I'm going to change it to degrees. Now, how could I possibly figure out how many degrees are with each one, Violet?
Well, you could either, in this case, I think you could use the number of students and then multiply it by 2, because the total is 180, and then you just get 360 degrees.
You could do that.
But usually, like if it's too hard, you multiply 360 by the percent.
Yeah, so what Violet's saying is our total number of students is 180. So if we multiply all these by 2, it's going to give us our number of degrees because it'll equal 360. That's one way to do it for this graph, right? That works for this one. But like you said, it won't work for all of them. So what we would normally do is we're going to take our percent as a decimal. So 44% would be the same as 0.44. And we're going to multiply it by 360. Because we know a full circle has 360 degrees in it. So if you take 0.44 and you multiply by 360, what do you get for your degrees?
158.
Let's go with nearest whole degree again. 158 degrees?
Yeah.
So then we take the orange, which is 8%. So 0.08 times 360.
29.
Okay, then we go to the banana. 7% is 0.07 times 360. 25. Okay, kiwi.
43.
Blueberry.
47.
And then grape.
58.
So it should total to 360 degrees, should total 100%. Now, here's the key. When you're drawing your circle, it's an estimate, guys. Right? No one circle is going to be absolutely perfect with the number of degrees they're putting in each part. Okay? The key is, don't make like 43 degrees look like this chunk here. That's not 43 degrees. That's almost 180. Right? It's an estimate, but you need to give it a good estimate. So, I normally like to start with the biggest one. The biggest one is apple. It's 158 degrees. Well, I know that if I start in the middle, I go straight up. If I go straight down, that's 180 degrees, right?
Yep.
So I'm going to shave it off just a little bit. So this is apple. This is 44%. Make sure you put some sort of label in there, right? Apple. And then tell me how big it is. Either 44% or do 158 degrees. Either one would work for me. Alright? The next one is orange. 29 degrees. Well, I know that's going to be total about 160, so, or excuse me, 190, so it's a little bit above the 180. It's a little bit past that straight down. So that's going to be orange, 8%. Like I said, it's an estimate, guys. Do your best. And just don't make something super huge. Banana, another 25 degrees, so a little bit smaller than the way I made orange. Already, so it's hard. Banana, 7%. Kiwi is 43 degrees. So almost double what I gave banana. Kiwi. And that was 12%. Lastly, I have blueberry, which is 47 degrees. I have grapes, which is 58. So I know the grapes one's got to be a little bit bigger. So grape, which is 16. Kiwi, or not kiwi, blueberry. Oh, bee-berry. We have 13 and 16. Does that make sense, guys? Right? Change it to percent and make sure you find the degrees. Once you have that thing, it's an estimate, drawing it on there. You need to have labels for each piece. You need to tell me how big each piece is. Right? And yours doesn't need to look exactly like this. If you want to turn it and you want to start with the apple like that, that's fine. If you want to start with the apple in the bottom, that's fine. But they need to be an estimate. There should be no reason for banana to be as big as apple. Right? They need to make sense. Does that make sense?
Are we gonna draw one of these on the like test?
I don't know. There's a possibility.
That one.
Okay? Alright, so that's a circle graph. Oh, look at it, they did it for me. Wouldn't that have been nice? Alright. Next thing, stem and leaf plots. Does anyone ever heard of stem and leaf plot before?
No.
I feel like we might have, but we'll go through it again. A special table. For each data value is split into a leaf, which is the last digit. The last digit of each number is your leaf. Alright? And a stem. All the other digits are your stem. So it says, what is a stem and leaf plot? I would probably write down a special table where each data value is split into a leaf, usually the last digit, and a stem, the other digits. You done? Can I have it? Oh, I'll take it, it's fine. Thanks.
I have it.
All right. Did you get a review yesterday? Okay. So, what that looks like is 32 will be split into a 3 for my stem, right? The other digits, and 2 for a leaf. He said the leaf is the last digits. So what would happen is all of our stems are listed on the left. Normally it's drawn like this. And then each leaf is separated after that. So the 3 would be my stem, 2 would be a leaf. Does that make sense? 23. 2 is the stem, 3 is the leaf. Okay? Trust me, we're going to try one and hopefully it works, okay? Alright. So, what's going to happen? Is it down here? So the stem values are listed down, the leaf values go right. Hey, please listen. The stem, they are not repeated. You see 23, 23, 26, 26. We only write 1, 2 down for our stem. But the leaves can repeat 3, 3, 6, 6. Okay? What this means is 15, 16, 21, 23, 23, 26, 26, 30, 32, 41. Right? So it has all of our numbers in it. It's just organized a little bit differently. Okay? So, when making a 7-leaf plot, you can either first put the numbers in order, or you can do the plot in 2 steps. We'll do our example doing it in 2 different steps. If you can do it by just jumping to the last step, you're more than welcome to. You don't have to do it in 2 steps every time. Right? So following your scores on a physics test. If I look at all these scores here, what are my stems going to be? What are the numbers you want to put on the left? What do you think? What?
The tens place.
The tens place. So like 7 will be 1, 8 will be 1, 9 will be 1, 6 will be 1. What about 100? What do you think we're going to put for our stem? 10. Thanks. You got a review? Yeah. Okay. So, what we're going to do is those go on the left side first. 6, 7, 8, 9, 10. Those stems go in order from least to greatest going down. This is our first step. Then, what we're going to do is we're going to take and we're going to list each of our data values. So if you look, the first number is 78. So I know I'm going to go to 7, and I'm going to put an 8 for my leaf. That's the first one. Then I'm going to put 74. I'm going to put a 4. Then 80. I'm going to put a 0. 84. Put a 4. Is this making sense? No?
Yes.
Are you lying or are you serious? So it's not making sense. Okay, so our first number, Paige. What's the first number in our list?
78.
78. So we're going to find our stem of 7, and we're going to put an 8 after it for 78. Okay? Then the next number is 74, right? So same thing, find your stem of 7, and we're going to put a 4. We'll put our last digit up there. Got it?
Yeah.
Okay, so we had 80 and 84, then 99, 65, 62, 95, 100, 91, 75, 82 and 80, 75, 100, 82, 77, 70, 90, 95, 86, 82, 75, and 69. Okay? So, that's our first step. What do you think our second step is going to be? Rearrange them and order them, right? So, once you have them all listed out like this, then all you have to do, so you're going to do it down here, put them in order. So then 6, we go 2, 5, 9, 0, 4, 5, 5, 5, 7, 8. So put it in order. If you can jump right from your list up top of numbers to that second step where you rearrange it, go ahead. Do it. Save yourself the time, alright? You're not going to get marked down if you don't do the first step and the second step. Alright? Go ahead and do it. Alright. Do we need a second to rearrange them yet? Okay. I can do that. About what, 15 minutes left? Guys, any questions on a stem and leaf plot? How to read one? Anything? Nothing? You good? Did you answer Coach Nitz? Can you play on Monday? No? Okay. Alright, ready to go on? Alright, Box-and-Whisker Plots. This is the other type we're going to do. It's a 5 statistical summary that is represented graphically. So, we are going to use the first and the third quartiles again. The upper and lower quartiles are at the ends of the box. So if you look, this is what a box-and-whisker plot looks like right here. Okay? So at the edges of the box, there's the box in the middle, and there's whiskers coming off, right? A box-and-whisker plot. The two ends of the box are the upper and the lower quartiles, Q1 and Q3. The median is indicated with the vertical line at the interior of the box. So the line inside the box is going to be where your median goes. And lastly, the outsides are the maximum and the minimum values of your set. Alright, so what this does is it shows us, it breaks it into 4 even quarters, or 4 even quartiles. And it shows us how spread out each quartile is. Does that make sense? So this is like the first quarter, the second quarter, the third quarter, the fourth quarter. And how far spread out it is, how far spread out our data is in that quarter of our data. Alright? Eldridge. Yeah, right. I will. Yep. Right. Down. Okay. Athletic office. Okay. Alright, so, like I said, they're helpful in telling you about the distribution of the data. You can go after. After class, yeah. So just wait so you can watch this. Okay. So, how to construct one. Is this the same data that you have up top? No. I'm not going to go through this. We're going to do it all together. So, height and shoe size. We're doing 2 box-and-whisker plots. Let's start with just the height. Wow, that's great. She's got her calculator out and she's putting the heights into list 1. That would be awesome. Go into the heights and into list 1 because we need to do what we call a 5-stat summary. The 5-stat summary includes those 5 pieces we just talked about. The minimum, Q1, the median, Q3, and the maximum. Those 5 pieces are what we're going to put on our box-and-whisker plot.
How do we do that again?
So stat edit.
There we go.
List 1, put them all in the list 1. And do your calculations. Find the minimum, Q1, median, Q3, the maximum. They're all in there if you keep scrolling down. Stat, calculate. So if you go down, you'll notice you have the minimum value of your data set. You have Q1, the median, Q3, and the maximum. It also asks for the mean. You can put that down. It's not part of our 5-stat summary. It won't go on our box-and-whisker plot, but it is nice to know. Okay? So remember, when we're going into that, stat calculate. We should have list 1 in there. Our frequency list should be blank. Right? If we don't have it blank, then we're going to get some weird frequencies in there, and it's going to throw off our data. So list 1, frequency list blank, and then calculate. If you haven't gotten there yet, just use the board. So our minimum value is 152. Our Q1 is 165. Our median is 168. Our Q3, our upper quartile, is 173. And our max is 183. 152, 165. 183. I think the mean was on 167.5. Like I said, guys, the mean isn't part of our 5-stat summary. It's not going to go on our box-and-whisker plot. It'll just be these bottom 5 here. Do you have a question, Tobias?
Yeah, I'm not getting any of that data online.
Did you put them on list 1?
Yeah.
If you just stat, calculate. Yeah, guys, once you put it in there and you hit calculate, you got to go down all the way to the bottom. Right? When that thing pops up, you can go up and down on it. All the way to the bottom will give you minimum, Q1, median, Q3, maximum. Okay? Did we all find that? Am I going too fast? Are we good? Yes, I'm going too fast, or yes, we're good?
Yes, we're good.
Okay. So, what we're going to do then is on our line? Well, first of all, we need to label our line, right? We need to put numbers on it. So I'm going to start by like 150, and I'm going to go by 5, so then 160, 65, 170, 75, 180, 185. All right, so my lines went by 5s. You can do it however you want, however fits your data. Right? It doesn't have to be the exact same as mine, just make sure it all fits on there and we're not skipping any numbers or anything. Once you have your line labeled, figured out what you want to have on it, then what we're going to do is we're going to plot our 5 stat summary, our minimum, Q1, median, Q3, maximum. Put 5 dots on there at each spot. So my minimum's at 152, put a dot. Q1's at 165, put a dot. Median, 168, dot. Q3, 173, dot. Maximum, 183, dot. Okay? Then what we're going to do, we're going to draw our box in. So Q1 and Q3 make the box. And then our median has a line in the box. Okay? Does that make sense so far? So remember, Q1 and Q3 are our box, and then we're going to create whiskers out to the maximum and the minimum. So we have our whiskers, we have our box, and our median. Alright? So, if you want, think of it as putting a line for the middle 3, and then connecting those lines. Right? That makes our box, and a whisker going out. Okay? Let's try it one more time with shoe size. Go ahead and put shoe size, or here, with this. You don't need to put shoe size in your calculator. I'll do it on mine, and you can use the data off mine. Is that okay? You okay with that? Alright. So it's in mine already. So stat, calculate 1 variable stats. Oh, what just happened? 1 variable stats, list 2. Okay, so if I go down, my minimum is 3. My Q1 is 6.5. My median is 6.75. My Q3 is 10, and my max is 12.5. The mean is about 7.8, if you want to write that down. You don't need it, though. It doesn't go on our box plot. Okay? So those 5 we need to have down. We said they were 3, 6.5, 6.75, 10, 12.5. This was 7.8. So, do we all have that 5-score summary down? Hey, that's a vocab word. This is a 5-score summary right here. Right? 5 stat summary. 5 stat summary. Minimum through maximum. Okay? So I'm going to go 3 through 10. I'm going to go by ones. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 through 13. Did I say 3 through 10 before? I meant 3 through 13, sorry. 3 through 13, I went by ones. Once again, I'm going to put my 5 stats down. Minimum is 3. Q1 is 6.5. Median is 6.75. Really close to each other. Q3 is 10. Maximum, 12.5. Alright, so like I said, if you want to think of it as, put a line through the middle 3, and then connect them, that'll make your box. And then draw your whiskers out. Okay? So what do you notice about that one? What do you notice with the second quarter in there? It's much smaller than the other ones, right? So that means our data around the second quarter, the middle quarter of our data, one of the middle quarters, is really close together. Alright, so if it's farther apart, our numbers are farther apart. If that part's closer together, they're closer together. Alright? Any questions on box and whisker? Okay, we have one last thing to do. It's really easy. Frequency distribution. It's by counting frequencies we can make a frequency distribution table. All you really have to do is if we go over here, if we look, all we're going to do is we're going to put, if 1 happens twice, we have 1 happen 2 times. 2 happens 1, 2, 3, 4, 5. So 2 happens 5 times. Right? We used frequency tables last unit. It's the same thing, but now we're making them. So, if Mr. Siebert surveyed his class to find the number of children that are in each of their families, there are the results. You don't have to put them in order, right? You don't have to put it 1 through 5 and then tally it. You can just tally it right away. So make tallies. 4, 2, 1, 5, 4, 2, 2, 3, 3, 1, 1, 2, 3, 2, 2, 3, 4, 1. I think we can all tally, right? We've all done that before. 1, 2, 3, 1, 1, 2, 1, 2, 3, 2. Alright, and then all you would have to do is write your frequency out. So 1 happened 5 times, 2 happened 12 times, 3 happened 6 times, 4 happened 3 times, 5 happened once. So if I asked you what the mode was for that, what would you say? 2. Why would you say 2, Q?
Because it repeated the most.
It repeated the most. It happened 12 times, right? Happened the least was 5. Does that make sense? Pretty easy.